All right, so express the integrals in infinite series. Let's take a look. And what are you going to do over here? I guess what we have to do is, it's an improper integral, by the way. I'm not worried about it. All right, you might say you're being sloppy by not being worried about it. I'm not worried about it. So what I'm going to do over here is write down the series for cosine. So the cosine of t is going to be 1 minus t squared over 2 factorial plus t4 over 4 factorial. And this goes on forever and ever, right? It converges for all real number t. And what I want to do is I want to look at this guy over here, and I want to discuss what I have to do with that. And it's going to be 1 minus that thing. All right, let me write that down for you. So, 1 minus the cosine of t. And what would you get there? You get 1 minus 1 plus t squared over 2 factorial minus t4 over 4 factorial. And then, yada, yada, yada. All right? I think I can do that. And what does that give you? Well, 1 minus cosine of t is going to be, let's see, t squared over 2 factorial minus t4 over 4 factorial plus t6 over 6 factorial minus yada, yada, yada. Very simple pattern, by the way. Now what I'm going to do, I'm going to do 1 minus cosine of t. I'm doing the integral, by the way. Divide by t. What does that give you? Well, again, I'm looking at this, and I want to divide it by t. What does it give you? T over 2 factorial minus t cubed over 4 factorial plus t5 over 6 factorial. Let me just write the next term down. And looking at it, the exponent's going up by 2. So it's going to be t7. And again, if you thought about it, the denominator, 2, 4, 6, 8 factorial. All right, so if I were doing homework right now, I wondered, did I do that right? All right, so we're going to look at the key, and I want to look at this part over here. We kind of talk through it. Am I getting what they said I should be getting? T over 2 factorial, t cubed over 4. It alternates, by the way. Yeah, we're getting it. All right, so what do you do now? Well, we know what the integral looks like as a series. We're going to integrate it now. So I want to get my eraser out. I'm going to start to erase things here. And yeah, if this is an exam, you don't erase your work, by the way. We're talking about me doing homework for you. So let me write this one down for you. This is equal to 0 to x. And you can get t over 2 factorial minus t cubed over 3 factorial. I'm sorry, not 3 factorial. I'm sorry about that. Let me erase this business too. 4 factorial plus t5 over 6 factorial minus t7 over 8 factorial plus yada, 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 dt. All right? Can we integrate that guy? We can. And let me go through that with you. Let me erase this business over here. And we're going to do the integration now. What does this give you? The first term is going to be t squared. And then the 2 comes down, so it's going to be 2 times 2 factorial. Minus t4, 4 comes down, times 4 factorial. Let's do the next one. Plus T6, 6 comes down, 6 factorial. It's got a very predictable pattern. T8, and 8 times 8 factorial. And this goes on forever. But we need to evaluate this at 0 and at x. Well, let's write it down. It's going to be x squared, 2 times 2 factorial, minus x4. We'll write it as a summation later. 4 factorial, plus x6, 6 factorial, minus x8, 8 times 8 factorial, and then plus yada, yada, yada. Now, what's nice about the lower limit, every single term is going to evaluate to 0. I think I'm good with that. So I'm going to write my sum down now, and the sum will look like this. Where do we start? I'm going to start at 2, off to infinity. You know what? I'm going to start at 1. You can start where you like, but I think 1's a good place to start. And I know it's alternating. Now I'm going to start at 0. Minus 1 to the n. That gives me that pattern, plus minus, plus minus, plus minus forever. And what goes on bottom? It is going to be, let's see, 2, 4, 6, 8. 2, 4, 6, 8. That's going up by 2. So I'll say 2n plus 2. And then 2n plus 2 factorial. Let me just see if that works. If n is 0, I would get 2 times 2 factorial. If n is 1, I would get 4 times 4 factorial. If n is 2, I would get 6 times 6 factorial. Yeah, it works pretty good. What goes on top? X to the 2n plus 2. Now, again, you might look at this and say, I wonder if there's another way to write that. Yeah, there's other ways to write it. I noticed I started at 1, so I'm going to rewrite it. This is infinity. That would be minus 1 to the n plus 1 instead. Let's do this over here. Now again, it's starting at 2, so it's going to be 2n. It might be a better choice to do that, by the way. It's a little easier to write that down. What goes on bottom? 2n, and then 2n, that quantity, factorial. Either one's fine, by the way. So this is a good answer, and this is a good answer. They're both good answers, all right? Thank you.